This video is brought to you by Squarespace. What's going on, everyone? It's Ozzy from OzTalksHW. How are you guys doing today? A few days ago, AMD released their highly anticipated Ryzen 3000 processors. I'm sure you guys have already seen the reviews. It's been over a week now, so I'll spare you the trouble. The TLDR, they're great, especially for the price. But there's one thing that I noticed between all of the reviewers. They all use the same high-end motherboard quality, the top-of-the-line X570 motherboards. Well, duh, that makes a lot of sense. You want to use the best motherboard that you can for a review. Yeah, I'm not knocking them whatsoever. It makes total sense to do that. But I would like to focus my attention to a demographic of cheaper people that don't have such high-end, such fancy motherboards. So, for all three of you out there with A320 motherboards, this video is for you. Or if you're just interested in the concept, this video is for you too. I arrived at my local Micro Center on July 7th around 8:40 a.m. and there was already a line of about 20 people. By the time the store opened, it had easily doubled. Anyway, I walked in, waited in line for a bit, and told the rep which CPUs I wanted. The 3900X, 3700X, and 3600X specifically for this test. Unfortunately, they limited only a single Ryzen CPU per customer that day to make sure that there was enough to go around. Totally understandable. I opted for the 3900X, picked up the A320M motherboard, and made my way home. Let's get tested. People say don't judge a book by its cover. Sadly, this doesn't really apply to the A320M S2H from Gigabyte. What you see is what you get. 4 SATA connectors, 2 DIMM slots, and a crummy 4-phase VRM. Not a lot, but when I installed the 3900X after a BIOS update, it booted. Ryzen 9 3900X 12-core, baby. We did it. We did it. In the other arena, we have one of the most powerful AM4 motherboards on the market right now, the X470 Crosshairs 7 from Asus. This thing can supply over 200 amps of current, which is totally enough for something up to like a 16-core processor. It'll be our reference point. My hypothesis for these tests is this. If AMD engineered this properly for stupid people like me doing stupid tests like this, then I suspect that the motherboard will throttle the CPU once the voltage and current specifications exceed that is rated on the motherboard VRMs. We should see a performance dip on the A320 board compared to the Asus one because of inadequate cooling and power delivery on the motherboard. And when I say motherboard temperatures, I really mean the temperatures of the MOSFETs, some of the components that make up the VRMs that surround the processor. Cheaper ones, like the ones on the A320 board, are rated for about 85 degrees Celsius, while higher end ones can go up to 125 or even 150 degrees Celsius. So now the question is, how do you record these temperatures? Well, you can use software like AIDA64, but because of temperature offsets and sometimes inaccurate sensors, those aren't super reliable. So instead, I'm doing them hardware-wise using K-type thermocouples and a thermometer. So I do want to give a quick shout out and thank you to Steve and the Hardware Unbox team. He helped me immensely. It was my first time ever measuring VRM temperatures using any kind of hardware. Thank you guys. I really appreciate all that you guys did to make this video possible. I attached the thermocouples to the back of the PCB directly behind the MOSFETs and attached them with a thin layer of Scotch tape. Fun fact, well, I guess it's not really fun, but I shorted the first A320 motherboard when I tried to attach these directly onto the PCB. Don't do that. We'll test motherboard temperatures during an AIDA64 stress test, a Cinebench R20 run, and 3D Mark Time Spy. This gives us a comprehensive look at the performance across 3 very different applications, and then we'll compare the frequency of each chip in each motherboard using hardware info. And here are the specifications for the test bench. I know that the RAM is pretty low and pretty slow, but this isn't a test of absolute performance, but relative performance between the 2 motherboards, so that shouldn't matter. And my hypothesis was more or less correct. The A320 board had much higher average and peak temperatures overall and gave me lower performance. The MOSFET temperatures doubled that of the X470 board and were reaching their thermal limit in AIDA64. This is worst case scenario, of course, and in Cinebench and 3D Mark, the numbers were more doable, but remember that these benchmarks last only a few minutes. The temperatures were still rising at the end, and I'm positive a long gaming session will result in higher temperatures. Now, if we look at the frequencies, we have some pretty interesting findings. If we look at the peak frequencies in both 3D Mark and in Ada64, the A320 is in the lead. It has the highest maximum frequency in both. But if we look at the average frequency in Ada64 over a 15-minute run, we see that the X470 expectedly is about 100 megahertz higher. The X470 board has much higher quality components, so the 3900X is able to sustain a higher clock speed. The peak frequency findings still kind of baffle me, but I'm assuming this is because of microcode or BIOS updates. Gigabyte was pretty quick to get all of their updates out, and that could result in higher boost frequencies. I know Asus was one of the last vendors to get their updates rolled out. So would I recommend an A320 board with the 3900X? I'm sure you guys already know the answer to this. Of course I wouldn't. That's not a smart move whatsoever. The MOSFETs on the A320 would degrade much faster than a better equipped motherboard. And you also lack a lot of features that enthusiasts who are picking up a 500 CPU would appreciate, such as more PCIe slots, more PCIe lanes, overclocking, precision boost, more I/O, more storage capabilities, just an array of features that these boards lack. But I will say that even though this A320 board was struggling with a 105 watt TDP chip, I'm 100% certain that it will be fine for a 65 watt chip such as the 3600. So if you have an A320 board, you're one of the 3 people in the world that do, and you want to upgrade to Ryzen 3K, then the 3600 gets my recommendation. I'm sure that'll be fine. I got to commend AMD for actually doing this. Just kind of think about this for a little bit. You have a 12-core $500 processor that in its own right is pretty crazy, and then you're pairing it with a $50 to $55 motherboard, and it works fine. I mean, there are issues, but it boots. You can actually test things on it. It's a compatible socket. That's just wild. Considering that there aren't any A420 or A520 boards, the update kind of makes sense for office computers or any kind of HPCs, OEMs that are upgrading to Ryzen 3K in the future. Now, before I go, we do have an advertisement. Thank you so much, Squarespace, for sponsoring this video. Squarespace is one of the easiest ways to make your own website. You can literally make an account and within an hour have the base template of your website completely done and looking solid. And you don't have to have any kind of programming or coding experience. I'm currently in the process of moving the OzTalksHW website from my current site host over to Squarespace. It's such a simple and easy project, and it's going a lot quicker and simpler than I expected. So if you guys are interested, then use the code OzTalksHW, get a discount on your first Squarespace website and any other products that they have, and start building your own website. But thank you guys so much for watching. Thank you for waiting for this video. I know I'm kind of overdue and late. Ryzen 3000 hype already died, but whatever. I want to share my findings. If you guys found it useful, then leave a like. If you loved it, share, subscribe, all that kind of stuff, because I have a ton more videos like this in the pipeline, and hopefully I can get them out before the end of the month. I'll see you guys in the next one. Peace.